Hello world, this is Alex Tran, and this is one of the many videos that we'll be making from now until January 12th. Around this time, I'm going to be solving a Leetcode easy problem. It's going to be randomized, and I'm going to give up after 15 minutes if I can't solve it in time. So let's get started. Let's go to Leetcode and find a random easy question. And no, I don't have premium. Oh, okay, fine. That's a hard one. That's a medium one. That's a medium one. Did I say medium Leetcode medium question? I meant like Leetcode easy question, not Leetcode mid. Nope, I don't want a hard one. Seriously? Count pairs whose sum is less than target. Given a zero index integer array nums of length n and an integer target, return the number of pair I and j where I is less than j less than n. What is n? The length of num. So, what do we even need this? J, this condition does not need to be existing because, so basically I need to be less than j because less than n, any number is gonna be less than n, less than zero. So it can be zero. Within the array, find the number I and j that within I if less than j, and the number of I less than j, number I plus j is less than target. So we are supposed to return number of pair from I and j. So note that 0 and 3, the output is 3. Less than target. And integer target. Return a number of pairs. The number of pairs I and j, where I is less than j, where I the number. Okay, so if it's 2, then we know that any number less than that is the sum of any number within this array less than 2 is going to be good. So -1 plus 1 is 0. That's good. That's 1. 1 plus 2, that's not going to happen. 2 plus 3, that's not going to happen. 3 plus 1, that's not going to happen. Then -1 and 1, that's valid. -1 and 2, that is 1, that's valid. -1 and 3, that's not valid. -1 and 1, that is totally valid, so that's 3. So now we move on to 1, that's not going to work. 1 with 2, that's not going to work. So we can't sort the array because we have to return I, because I need to be less than j, basically. So now we'll go -6, -6 and 2. The target is -2. So -2 plus 2 is a -4, so that's valid. So I think I kind of get this. How would I approach this? So I would have 2 for loop. This is going to be an of n square operation, unless there is like a way to optimize it. Let's just brute force it first and then come up with like an optimized solution. So it's going to be 2 for loop. The first for loop is going to be looping through each one of this number, and the second for loop is going to be checking the number next to that for all of it. If the number is less than the target, then we're going to +1 to the output. If not, then continue. That way I is always less than j. So how I'm going to do this is I'm going to do sum total is equal to 0 initially, and we're going to return total no matter what. So return total. What are some edge cases that I can see? The array is empty. Hang on. The constraint is 1 num.length. So there's always going to be 1 number inside of that. So if the array only have 1 element and return, then we can't do anything. If the number is -50, +50, that is totally fine. We don't have to like worry about out of bound buffer overflow, whatever that can call. So that's totally fine. So there is maybe 1 element in the array that might break my code, but we're gonna run the code first and then to see if that breaks it, and then deal with that later if that doesn't break it. Otherwise, I'm just gonna write in like an extra if else statement. So for I in range in range of nums, for j in range of length of num, from I moving forward, because we don't want to check to see if, okay, so we just want to test this out real quick. We're going to print out nums at so total is equal to no if current sum, so we're gonna have a variable that keep track of the current sum, right? Current sum equal to nums at I plus nums at j. So if current sum is less than target, then we're gonna append total plus equal to 1 and return total. What? We output 3 and expected 4. Output 4, expected 3. Target is 2. Okay, so we want to know when we got into this block right here. So print cur sum and num at I and num at j. I might be dealing with an off by 1 bug. This is the most situation. Nums is not the variable. Okay. For nums, I knew getting a mechanical keyboard is a mistake. So what the time that we're in here, -1, -1, -2, -1, -2. How do we end up with a -2? Where do you get -2 from? Current sum is -2. Okay, -1 plus -1 is -2. 0, 0, the sum is 0. -1 plus 1 is 0. -1 and 2 is 1. -1 and 1. Why don't we just print out the index? That way we can get a better view of this. Oh no. 0, 0, that's valid. 0, 1, that's valid. 0, 2, that's valid. 0, 4, that's valid. Hang on a minute. Less than n. The size of the array is 0, 1, 2, 3, 4. So am I not supposed to check the last element? 0, 0, 0, 4. 0 and 4. -1 and 1. So am I not supposed to check the last element? Okay, okay, why don't I just do -1 here? Output 10, expected 11. Open raw. 4 and 5. 1, 2, 3, 4, 5, 6, 7. 4 and 5. 0 and 1. That's valid. 0 and 3. That's valid. There is no 0 and 0 in here. And that's my... Oh, wait a minute. 0 and 0. I plus 1. Because the first index is going to be 0, right? For I plus 1. Run. And then we're going to know, maybe that's where my off by 1 bug is coming from. Yay. Yay, that worked, and it beats absolutely no one. Okay. I want to see what the top solution is. I want to see. Yeah, this guy used a true loop here. Wait, hang on, does he use a true loop? For n equals the length of num, for c equal to 0, for I equal to the range of n, for j equal to I plus 1 and n. Does it check to see if the current sum, if current sum is less than target, c plus 1 plus equal to 1. So under the hood, I'm saving this to a register, right? And I'm comparing it using, I'm using another register to compare it. So we can probably just omit this to make it faster. Hang on, let me see what he did. Oh, we're printing it out too, so that's why. Total plus 1. Maybe the printing it out is probably slowing it down a little more than it should be. What? How is it too slow? Is length of num being called every time? Okay, why don't we just have another variable called length is equal to length of nums. I bet that's where it's messing. That's where maybe that is gonna slow down that we are not expecting here. Length of L, length of num. Submit. Now my code basically looks like his code. Okay, so that guess the length of num is maybe slowing it down a little more than it should be. Looking at the most optimal solution, I don't think there is another optimal solution for this problem. Unless there's an O of n operation that we can probably figure it out, but this is more like an O of n squared operation. So yeah. Solution. I want to see this fastest solution. Your solution. Yeah, these are all brute force solution. We're gonna find. Let's just try to find an O of n solution from this one. O of n and solution. The array is not sorted. That's the problem. I mean, we can add the entire thing to the array, right? We can add everything to a hash map, but then we still need to check to see if it's in the hash map. We can go through once, add it into a hash map, and then we can go through it again, checking to see if no. If we add everything to a hash map, we still need to loop to the hash map to see if that number is less than the sum. Yeah, this is gonna be the most optimal solution here. I don't think this is a faster solution. So yeah, that's been the video. Have a good day. Bye.